Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 6, Chemical Foundations, Part 6. Here are our objectives for today's video. Pause here. So if you didn't already know it, temperature is just a measure of the average kinetic energy of a sample. And we have 3 temperature scales that we're going to be using. So being Americans or American living people, we are very accustomed to using Fahrenheit, but most scientists use Celsius because it is much more intuitive when we're doing things like calorimetry experiments, things like that. And then there is another scale called Kelvin, which is useful because Kelvin cannot be negative. So when we have to do like calculations where we can't have negatives, which we'll do some experiments with, that's when Kelvin is useful. Although we will usually use Celsius in the lab. We will want to be able to convert between the 3. And here are 3 equations. These are on your equation sheet, so you do not need to memorize them. You just need to be able to use them. Do be mindful of significant figures with this. Pause here. So first thing I want to point out before I start working on this is that Kelvin does not have degrees associated with it. That is just Celsius and Fahrenheit that do. So you do not put the degree symbol next to Kelvin. Right, so I've got 298 Kelvin. I want to convert this to Celsius and to Fahrenheit. So I'm going to start with this first equation here, plug in 298, and then I just have to do my subtraction. When I originally put this in my calculator, I get 24.85, but 298 is precise to the nearest 1, so I have to round to the nearest 1, so I get 25 degrees Celsius. So now I want to convert this to Fahrenheit. So I take this equation here and I plug in 25 for TC. So I get 45 plus 32. I get 77 degrees Fahrenheit. Because of the fact that the relationship between Kelvin and Celsius is an addition relationship, you may have different number of significant figures between Kelvin, Celsius, and Fahrenheit. Celsius and Fahrenheit will almost always be the same, though. Pause here. Right, so there's actually 2 different ways to do this. I'm going to show you one of the 2 ways. I pick either one of these equations, and I just make both of the t's equal to one another because they're the same number. And then I just solve. So I'm going to subtract 1.8t on both sides. Divide by negative 0.8 on both sides. And I'm going to get negative 40. This is not really a sig fig thing since we're looking for an exact number. So negative 40 degrees Celsius is the same thing as negative 40 degrees Fahrenheit. Pause here. So by this point in time in the year, we've probably even done experiments with density. And you've seen this probably in middle school as well, just mass over volume. But we can use this as a unit factor in calculations. This will pop up when we do our stoichiometry chapter, which will probably start in December or January, depending on a couple of things. But we're going to need to be able to use density as a unit factor. Let's take a look at an example with it. Pause here. Before you get started with this, I will just say that the 1.492, unless I otherwise specify, you can assume is a constant. So if I tell you the density of something, you may assume it is a constant unless I specifically say that it came from an experiment. Right. Let's work through this problem. So you could algebraically rearrange d equals m over v and you would get the correct answer, but I highly recommend that you do this with dimensional analysis because when we do a future chapter, it will make your whole life a whole lot easier. I have grams up top, so I want grams on bottom. Grams cancel with grams, and I round to 3 significant figures. I take a moment and I think to myself, does this make sense? And yes, it does. Because I've got this density that is higher than 1, it makes sense that my milliliters would be smaller than my grams. I need to cancel milliliters with milliliters, so my 1.492 grams goes up top. I round this to 2 significant figures, and I get 980 grams. Think to myself, does this make sense? Yes, it does. I have to convert kilograms to grams before I can use density. And then I want to cancel grams with grams, so 1 milliliter goes up top. 1.492 grams goes on bottom. And then I round this to 2 significant figures. So 800 milliliters. I take a moment and think, does this make sense? And yes, it does. Okay, that's all for tonight. Thank you so much for watching and have a great night.